Hello everyone, welcome to Pepcoding. So in this video, we are going to solve the next question, okay, of our Python series. So the question we have this time is from time and space complexity module, and the question is count sort. So let us see what is count sort. Okay. So as the name suggests, count sort is a sorting technique. Okay, it's a sorting algorithm. Uh, which is used to do sorting again, okay, which is used to do sort. In this question we are going to use count sort for sorting an array, okay. So we have so many sorting algorithms, right? So why this count sort is so much important and why we are using this? So let us see. So we use count sort. First of all, let us know that at what cases we are going to use count sort. We use count sort where the range of array means suppose we have array 59430 -125 875 4 985 68 1 5 10 0 1. Okay, we have this array, okay, but the maximum value of this is 10 and the minimum is -1, right? So the range is going from -1 to 10. Okay, so that means only 10 plus 1 plus 1, then that means only 12 elements are there in this array. Okay, only 12 unique elements are there in this array, so range is not too high. So we use count sort where the range of the array is not that much. Okay, that means the max and the min is not fluctuating too much. That means max minus min is not too high. Okay, let us say an example of JEE. We know about JEE means and advanced. So in that, lakhs of students give the exam, right? But the number varies from 0 to 360 only on the basis of what the ranks will be decided. So in these cases, we can use count sort where count sort can do effective sorting. Okay, the time complexity of count sort can also be O, and in the best case, which is really efficient, very much efficient. How is it O, and we'll discuss this later. But this 0 to 360, okay, I said O and in the best case only, okay, O and in the best case only. And second thing is we are going to use the space in it. We are going to use space in it, so that is why we are asking that the range will not be high. Range will not be too high. So in this case we can use count sort. Okay, we have seen a real life case, and next will be what we can do is, let us take an example first of all. Okay, let us see that how we can do the sorting using count sort. For that we are going to take this input. Okay, so let us say we have this array. Okay, we have to sort this using count sort. So how we are going to use this? So let us see how to do count sort. Okay, how to use this count sort. So first of all, for this we have to make a frequency array. Okay, first of all we will make a frequency array. So how frequency array will be made, and what will be the size of frequency array? So as I have told you that we are going to use the range in it. So what will be the range? First of all, let us see that. Let us see what will be the range. So the range would be see, we will be given a max, we will be given a min. Okay, we don't have to calculate this. We'll be given the max of the array, we'll be given the min of the array, and then we will find the range. Range will be max minus min plus 1, right? Range is max minus min plus 1, simple. So in this array the max is 7, min is -2, so the range is 7 minus -2 plus 1. That means 10. 10 is the range. That means the number which will be in the array can only in the range 10 only. Okay, in the range 10 only. So that means we'll make a frequency array of size 10 only. So 1 2 3 4 5 6 7 8 9 10. Okay, so we have a frequency array of size 10. 0 1 2 3 4 5 6 7 8 9 10. So we don't want this. So here is our array. Okay, 1 2 3 4 5 6 7 8 9 10. So this is our array, and what we need is we need to fill this frequency array. So this is frequency array. So what we will fill in it? We'll fill the frequency in it, right? We'll fill the frequencies in it. Frequency of number. So it is index 0, it is index 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It is our index. Now, how we are going to fill this frequency array? This is what we have to understand. So let us see. First of all, we need to understand that at what index I will give the frequency to which element. Okay, to which element in the frequency array I'll give the frequency. Okay, to which element. Okay, in which index I'll give the frequency to which element. This is what I have to figure out. So what I can do is, see, I have numbers from -2 to 7, and I have a frequency array of size 10, and these elements in this range will be from -2 to 7 only. There are 10 elements only. Okay, so I'll start -2 from here and 10 will be here. Okay, so and the rest will be -1 0 1 2 3 4 5 6 7 will be here, not 10, 7, right? 7 is the last element, so 7 will be here. So put 7 here. So this is how I'm going to fill my frequency array. I have given this indexing to my frequency array. Okay, I have given this frequency to my indexing frequency array. So how I'll be giving this frequency array indexing in my code? How I'll be giving this? I'll be giving this by saying, suppose I'm visiting at number 7, right? So 7 minus min will be the index. If I'll subtract the min from the number, I'll get it index. So min is -2, right? So 7 minus -2 will give me the index for it. That means 9. 9 is the indexing for 7. Okay, so this is how I gave the indexing to it. So we are done with it. Now we have to fill this frequency array. So how I'll be filling it? I'll be first traversing in this array and checking that which number I'm visiting. I'm visiting 7. Go to the index of 7 in the frequency array. Okay, it is in 9. Okay, increase the frequency there. Initially it was 0, we give it 1. -2. Go to the index of -2. Here is it. Give it frequency 1. Okay, I mean increase its frequency. 4. Go to the 4. Increase its frequency 0 to 1. 1. Increase the frequency. 3. Increase the frequency. Rest will be 0 0 0 0 and 0. Okay, now the next thing that we are going to do is, it is frequency array. Okay, it is frequency array. Next thing we are going to do prefix sum array. So prefix sum array. What is prefix sum array? Prefix sum array tells me the position at which my last index will come. The position at which my last index will come, that will be told by my prefix sum array. Okay, let us see how we are going to make this prefix sum array. So suppose I have this array and I'll erase this. Prefix sum, as the name is suggesting, prefix sum, that means sum of the prefixes, that means sum of the previous frequencies. Okay, sum of the previous frequencies is my prefix sum array, will be in my prefix sum array, and that would be telling me that at what position, not index, at what position my last index will come, my last number, at what last position this number will come. Okay, this is what it will tell me. So do one have any prefix? No, it doesn't have. So 1 will be the prefix sum for this -2. Okay, now -1, prefix sum means sum of previous frequencies and its own frequency. So it will be 1 only, because 0 plus 1, it will be 0 plus 0 plus 1, that means 1. It will be 1 plus 0 plus 0 plus 1, that means 2. So we are not going to do this like this, like 1 plus 0 plus 0 plus 1. We are not going to do like this. We just know that in the previous index we already have prefix sum, that means sum of previous frequencies. So what we will do, frequency at this plus this, frequency at this plus this. Okay, so frequency at 2, 0, 0 plus 2, 2, 1 plus 2, 3, 1 plus 3, 4, 0 plus 4, 4, and it is 4, and it is 1 plus 4 5. Okay, so this is what I have in the prefix sum array. So I have my prefix sum array, I have my frequency array. Now what I'll do is I'll make an answer array. I'll make an answer array. But before that, I want to tell you one more thing. Suppose some student may have a question in their mind that you have frequencies, you have numbers in the order. We have frequencies and we have number in the order. So you simply do this like you have 2 and you know that it is coming 1 times, right? Frequency means how many times it is coming in the array. So you have -2 initially, it is coming 1 time, write -2. You have 1, it is coming 1 time, write 1. I mean write 1, yeah, write 1. You have 3, it is coming 1 time in the array, write 3. You have 4, it is coming 1 time in the array, write 4. You have 7, it is coming 1 time in the array, write 7. So this is how it is sorted, right? This is how it is sorted. But this is giving me the right order. But it will not be a stable sort. It will not be a stable sort. We are doing count sort just not because of the time complexity, but because of this stable sorting. Count sort is a stable sort. How is it stable? Let me tell you what the stable means. So what the stable means is when we do count sort, then the relative order means, suppose I have this array like 2 5 4 3 5 1 5 9, okay, and this is, suppose it is 5 double dash, it is 5 dash, and it is 5, okay. So say if we'll sort in this order, then we don't know that 5 double dash and 5 dash and 5 will come where and where, okay. We don't know that it will come where. But in count sort, the order of this will be like this. In the end, 5 double dash will come, before that 5 dash, and in the first it will 5 will come, okay, only 5 will come. So the relative order will remain same. So this is called the stability, okay. The sorted order, the relative sorted order will be same as that of original array, original relative order, okay. So this is what is called relative sorting. This is what is called relative sort. So this is why the count sort is really special, okay, because it is a stable sort. It is a stable sort. So we know that we don't have to do this because it is not stable sorting, okay. We don't have to do like the sorting from this frequency array. We don't have to do this because it is not stable, okay. It is not necessary that it will be stable sort, okay. So what we are going to do is we are going to make this prefix sum array. This will tell me that at what position my this number will going to come in the end, okay. So -2 will going to end at 1 position, first position means 0 index, right? First position means 0 index. If I'm saying I'm standing at position 1 in the array, then that means you are at the index 0, right? Position 1 means index 0, position 2 means index 1, position 3 means index 2, right? This is what the relation between position and index. That means index is position -1, right? This is what the index is, okay. We understand the relation between the position and the index. Now what we will do is we will make a answer array. What will be the size of the answer array? Answer array will be same size as that of the original array. So original array was of size 5, right? So make an array of 5, 3 4 and 5. So 1 2 3 4 5, it is enough. It is enough, okay. So this is how, this is what we are going to do right now. We will make a frequency array. We have made a prefix sum array. Now we are making our answer array, okay. So we'll fill our answer in this. So for filling the answer, what we will do is we'll start from the end. We'll start traversing from the end. Why from the end? Because we need to save our relative order. We need to save our relative order. So if some element I'm getting in the end, I'll try to keep it in the end of the array, answer array, okay. I'll try to place it in the end of the answer array, okay. This is why I'm traversing from the end. So if I'm visiting, there are 2 5. If I'm visiting this 5 first, then I'll be putting this 5 in the end, then after that this 5. This is why I'm starting from the end, okay. I hope this is clear. So we know that why we are starting from the end, we know that what we have to do now. Okay, so let's start traversing from the end. So if I'll start traversing from the end, then I'll see I visit 3. Okay, go to the position of 3, go to the index of 3. 3 is at index 5, right? Now ask that at what index should I dump it. It is saying at position 3. 0 1 2 3 4. It is saying at position 3. Position 3 means at second index. At second index dump 3. At second index dump 3, because position 3 means second index, and decrease its this. What is this? Decrease its prefix sum, right? And say that the next element, next 3 that will come, will be at 2 at the second position. Okay, will be at the second position, and index will itself, it will be decided. Okay, now I went to 1. Go to the index of 1. 1 is at 3 index, right? Ask where should I dump it. It is saying position 2 means index 1. Index 1 dump 1. Okay, done with 1. Go to 4. One more thing, decrease it. Okay, now 4 is at 6, right? And it is saying position 4 means index 3. Index 3 dump 4 and decrease at 3. So now minus 2 saying 1 position, that means 0 index. Okay, 0 index, and place minus 2 at 0 index, decrease its frequency, it decreases prefix sum, that means here it is 0. Now 7, go to the 7. Index of 7 is 9. Ask where should I dump it. It is saying position 5, that means index 4, dump 7. Okay, so this is how we are going to fill our answer array. Okay, so our answer array is filled. So this is how we are going to do it. Okay, so I hope that it is clear. Let us write the code for this. Same thing we are going to do this. Let me again tell you the steps that I followed. Okay, let me again tell you the steps that I followed. So the steps were, first of all, frequency array, fill it. First of all, frequency array, fill this array. Then prefix sum. Why prefix sum? Prefix sum is going to tell me the position at which I'll be coming in the end. Okay, the last position at which I'll be coming. This is what prefix sum is telling me, not the index but the position. Okay, now from this prefix sum array, fill your answer array. And the last index will be, we need to change our original array, right? We need to change our original array, we don't need to return our answer array, we need to change in the original array. For changing in the original array, just traverse to this array and fill the element of this to our original array. Okay, so this is what we need to do, just the first step. So let us write the code for these 4 steps. Then after that we will see that what is the time complexity for this count sort. Okay, so let us write the code. So for code, first of all we need size, right? Frequency size. What will be the size of the frequency array? It will be range, right? Max minus min plus 1. So this will be the frequency array size. Make a frequency array. So it will be FARR equals to, give it 0, and the size will be f size, right? This will be the size of the frequency array. Now what we have to do is we have to fill this frequency array. So for I in range 0 to length of array, right? So in this range you have to fill it. How we have to fill it? First of all, val is equals to ARR at I, right? Now find the index. IDX is equals to this ARR at I minus min, right? This will be the index at which I have to increase the frequency. Now increase the frequency at that. So that means FARR at I dx plus equals to 1. Okay, increase the frequency by 1 there. So done with it. If I increase the frequency, now I'll make it the prefix sum array for I in range 0 to length of FARR, right? Because now I'm going to make prefix sum array. And which array will I make the prefix sum array? I'll make the frequency array my prefix sum array, right? How I'll make it? Okay, first of all, I'll start from 1 because 0 doesn't have any prefix. So what I'll do is I will why I'm starting from 1, the reason for starting from 1 is 0 doesn't have any prefix, and the frequency array and the frequency that 0 contains will be the same as in the prefix array. Okay, so this is the reason I'm starting from 1. So what I'll do now is I'll FARR at I is equals to FARR at I own frequency plus previous frequency, FARR at I minus 1, right? So this will be my frequency, and done with this frequency array, right? Now what we'll be doing, answer, right? So answer is equals to, the size of answer will be length of ARR, right? Why we are giving it the size? Because we are going to use the indexes. So for I in range, so here we are going to start from the end, right? Here I'm going to fill my answer array. So answer array will be filled from the end so that the relative order could be same, okay, so that the stability could be maintained. So I in range, length of ARR minus 1, length of ARR minus 1, comma, last index will be minus 1, right? Because it is exclusive, we do not include this, it is exclusive, so it will reach till 0 only. Last index would be 0, so that is why if you want to reach to 0 index, we need to give it minus 1, okay? Because if we will give it 0, then it will go to only 1 index, okay? Because last one is exclusive. So here yeah, minus 1 means go, this is the simple loop, I hope you understand it. Minus 1 means take one step back, okay? Minus 1 means take one step to the back side. So now I have to fill my answer array. So how am I going to fill my answer array? First of all, see, let us go to this. So how am I going to fill my answer array? I'm visiting this, okay, taking out this value. First of all, taking out this value, going to the index, taking out this value, going to the index, asking at what index should I dump it. Okay, first of all, val is equals to array at I, right? Taking out the value, making the checking what is the index. So first of all, position will be FARR at val minus 1, right? At this position, this will be the position. The frequency array, that means the prefix sum array is going to tell me at what position should I dump it. It will tell me the position, but I need to dump it at some index, right? So now I'll dump it at answer at position minus 1. At this index, dump what should I dump? Dump your val, okay? Dump your val or ARR at I. You can say this. Dump your ARR at I. Don't forget to decrease the prefix sum. That means val minus min minus equals to 1, right? Don't forget to do this. And now one more thing is remaining, and that is traversing to our final array for I in range 0 to length of ARR, right? 0 to length of ARR, traverse in this and give answer at I mean array at I equal to answer of I. Answer at I. So this is what we have to do. Array at I equals to answer at I. So this is what we need to do, right? So let us check it once. So first of all, what we did, we make a frequency array, okay? Frequency array of size max minus min plus 1, gave it the size, and then filled the frequency, and then make it the prefix sum. Second step. Then the third step is made an answer array. Okay, made an answer array, it is clear. And then here I started a loop from the end. Why from the end? To maintain the stability, okay? And then take out the value, went to the position, that at what position should I dump my number, and then it told me the position. I went to the index, okay? Index is position minus 1, then I dump my number there, okay, and in the answer array, and then I decrease the prefix sum, okay? And here it is here it is my loop to fill my original array. Okay, so let us give it a submit. I hope that this code will run correctly. So let us give it a submit. So it is accepting in the first time. Final submit. Okay, correct answer. So code is completely correct. I hope you understand that what I have told you. Okay, and you understand that how it is maintaining our stability. Okay, and one more thing I want to tell you, that is the time complexity. That is the time complexity. Let us talk about that. So the time complexity for this is O of n plus k. How is it? See, we are k is the range. First of all, what is k? K is range and n is number of elements. Okay, n is number of elements. So k is range and n is number of elements, and number of elements in the array. Okay, and one more thing, see, how is it n plus k is, we are traversing this frequency array, right? And this is of range k, so that is why n times this, and this k times we are traversing this, so it is making it n plus k. Okay, it is making it n plus k. We are not using two loops anywhere, so here it is n plus k only. And suppose if this range, if this k is range, right? If this k range will lie under this n, that means if it is less than or equals to n, then what will happen? O of n plus n, right? K will be less than or equals to n, means let's say k is equals to n. Okay, less than n will be something, suppose n minus 1 or n minus 2, but let us take n. Okay, O of n plus n, that means O of 2n, which is linear. The only type of sorting which can do sorting in linear time complexity. Isn't it cool? It is. That is why we are using this concept. That is why it is so important, because it is giving us answer in just O(n) time complexity in the best case. And the best case will be, best case is where k, I mean range, where range will lie under n. Okay, under the size of array, where range will lie under the size of array. That would be the best case, and in the best case it would give us the time complexity of O(n), and the space complexity that we are using is k. Okay, k, we are using the k. If k is the range, then we are using k extra space, so the space complexity is O of k. Okay, so I hope that you got this concept, this question completely, and it is a really cool question. So after this we'll meet in the next video, and don't forget to like the video and subscribe our channel, and share it with your friends, and we'll meet in the next video. Now till then, goodbye, take care, and give thumbs up.